today I want to prove that cosine squared plus sine squared is equal to 1. So let's get into it. Well, the first thing that we want to do is take a look at a right triangle and see what we can come up from that. Well, if we call this C, and this A, and this B, and we know this is our right angle, and we call this angle theta, right? We can say, well, what is our sine of this triangle? Well, let's recall that sine is opposite over hypotenuse. In this case, our opposite is A, and our hypotenuse is C, right? So sine of theta is equal to A over C. Well, now let's take a look at cosine of theta. Well, let's recall that cosine of theta is equal to what? Adjacent over hypotenuse. In this case, our adjacent is B and our hypotenuse is C. So we have B over C. All right, now what we want to go to is what we wanted to look at is the Pythagorean theorem, which is A squared plus B squared equals C squared. All right, now we want to divide all sides by C squared, because that keeps this equality true as long as we divide everything by C squared. And what we end up with is A squared over C squared plus B squared over C squared equals C squared over C squared. Anything divided by itself is 1. Equals 1. All right? Then, if you recall from exponent properties, what we can do when we have a fraction of some thing raised to a power over another thing raised to the same power is we can take that power out, right? So what we can do is we can turn this to A over C squared plus B over C squared equals 1, all right? Then we can look down here. Well, we already did the hard work, all right? We know that sine squared equals A over C, right? So we can say this is sine, or sine of theta squared plus, well, we know B over C, right? We already did the work. B over C equals cosine of theta squared, which is equal to 1, right? Because if these are equal to this, we can substitute them in, and that keeps it the same, right? So something to note, right, with the notation of when you have a trigonometric function like sine or cosine or tangent, and you square it, what you're going to do is you're going to take that exponent and you're going to put it here in front of the theta. And I'm not a huge fan of it. It confused me at first. It might confuse you at first, but that's what you're supposed to do. That shows that this is sine squared, or sine theta squared. All right, so now we have sine theta plus cosine theta, sine theta squared plus cosine theta squared equals 1. We've proven it from the Pythagorean theorem. Now, another way to think about it is off the unit circle, right? If we have some line going off the unit circle, and we have a right triangle, right? We have our point up here and our hypotenuse. Well, by definition of the unit circle, our hypotenuse, right, which is our radius, is going to be 1. So we can say this is equal to 1, all right? And if you remember, maybe you watched my unit circle video, you'll remember sine is equal to y, and cosine is equal to x. When we're finding distance, or the hypotenuse of a point, it's x squared plus, in this case it's going to be y squared equals, in this case it'll be 1. All right, we know x is cos of theta squared plus sine of theta squared equals 1. Now, a question you might have after that proof is, well, does this only work for the unit circle then when the radius is 1? And the answer is no. And why is that? It's because as our radius grows, so does our perimeter or our circumference. So it's all going to grow proportionally, so it still works. Now, why do we actually care about the Pythagorean identity? Well, we should care about it because if, say, we are given, if we have, let me rewrite it back up. If we are given an angle of cosine or sine, we can now figure out the sine or we can figure out the other angle based off that, because now we would have just one variable to solve for. Now with this as well, we can also solve for the other Pythagorean identities. For example, if we divide all sides by cosine squared, equal, yeah. We get, well, cosine squared over cosine squared is 1, right? Then sine squared over cosine squared. Sine over cosine is tangent, but now we have the squared, so we can say this is tan squared of theta, right? Equals, well, this, right? 1 over cosine is the same thing as secant, but now we have cosine squared, so this is secant squared of theta. And that's why you don't really need to memorize the other identities. If you just know sine squared plus cosine squared equals theta, you can figure the rest of them out from that. Thank you for watching. Let me know if I said anything wrong or if you have any additional feedback. Have a great day.